Good afternoon, guys. Welcome back into my channel. So in this lecture, we're going to talk about OSPF version 3. And after this lecture, we're going to configure multi-area OSPF version 3. So as I told you on previous videos, so this CCNP, this is a PDF book on the CCNP Encor. So if you stop into my channel watching this video, I'm gonna leave a link of this book in the bottom of each of the videos. You could have it for free, and I'm gonna leave the lab simulations and everything. So it says that in chapter 10, OSPF version 3. So this chapter covers the following subject: OSPF version 3 fundamental, OSPF version 3 configuration, and IPv4 support in OSPF version 3. So let's go ahead and here it says like OSPF version 3 fundamental, support for multiple address familiars, OSPF version 3 support IPv4 and IPv6. So OSPF version 3 link state advertisement. OSPF version 3 packets use protocol ID 89, and routers communicate with each other using the local interface IPv6 link local addresses. The OSPF link state database information is organized and advertised differently in version 3 than in version 2. So keep that in mind. OSPF version 3 modifies the structure of the router LSA type 1. We name the network summary LSA to the enter area prefix LSA, and we name the ASBR summary. So LSA to the enter area routers, enter area router, LSA. The principal difference is that the router LSA is only responsible for announcing interface parameters such as the interface type point-to-point broadcast, NBMA point-to-multipoint, and virtual link and metric costs. So SPF communication packets uses, I see here, it's giving you the LS type, the router, every routers generate routers LSA that describe the states and costs of the router interface to the area. So the network designated routers generate network LSA to announce all of the routers attached to the link, including itself. Enter prefix. So you could read that yourself by yourself. So says the local interfaces IPv6 link local addresses as the source. Depending on the package type, the destination address is either a unicast link local addresses or multicast link local scope address. So every router use all SPF, all routers multicast addresses FF002:5 to send OSPF hello messages to router. On the same link, the hello messages are used for neighbor discovery and detecting whether a neighbor relationship is down. So the DR and the BDR routers also use this address to send link state update and flooding acknowledgement messages to all routers. Let's go ahead here and see the hello, the packet name, the type, the packet name, the source, the destination purposes. So you could take a look at this yourself. Now, OSPF configuration. It says that the process of configuring OSPF version 3 involved the following steps. So initialize the router process as a prerequisite. IPv6 unicast routing must be enabled on the router. Afterwards, the OSPF version 3 process is configured with the command router OSPF version 3 processes ID. Define the router ID and the command and stuff like that. So you could take a look at this yourself. And this is a little demo here on what you got to do. The commands on different routers. So note, earlier version of iOS used the command IPv6 router OSPF for initialization of the OSPF process and IPv6 OSPF process ID area. Area ID for identification of the interface. This command or consider legacy and should be migrated to the ones used in this book. So OSPF version 3 verification, the command for reviewing OSPF version 3 settings, the status. So show OSPF version 3 IPv6 neighbor. So that's it. Let's go ahead and see if there's anything else that we should look at here. So a common mistake with summarization of IPv6 addresses is to confuse the EX, the hexadecimal, with decimal. We typically perform summarization logic in decimals. And the first and the third digit in an octet should not be confused as decimal values. For example, the IPv6 address 2001 : dash dash 1/128 is not 20 and 1 in decimal format. So the number is 2001 dash dash 1/128 is 32 and 1. Okay. OSPF version 4 support the OSPF version 3. IP version 4 support OSPF version 3. OSPF version 3 support multiple address families with setting the instance ID value from the IPv6 reserve range for the IPv4 reserve range 64 to 95 in the link LSA. So ensure that the IPv4 interface has an IPv6 address global or link local configuration. Configured. Remember that configuring the global address also place the global address alternatively, and the link local address can statically be configured. So look back. So that's a simulation here. Like I said, you could have these books. So if you wanna, learn this, get to know them before we take the test. The little lecture note that I prepared, let's just jump on it real quick. So it says here, OSPF explanation with example. So what is OSPF version 3? So OSPF version 3 is a link state routing protocol for IPv6 as a processor. OSPF version 2. In IPv4, OSPF version 3 still use autonomous area to separate network into areas. OSPF version 3 uses an IPv6 multicast address range of FF02-5. The OSPF routes and FF02-6 for OSPF designated routers. When sending update and acknowledgement, OSPF routers generate routing update only when a change occurs in the network topology. When a route link change state, the network device that detects the change creates a link state advertisement, LSA, and forward it to the DR using the FF02-6 multicast address, who inform all devices within an area using FF02-5 multicast address. Each device then updates link state database. One of the new features of OSPF version 3 is the ability to assign the router ID and area ID, and the link state ID with a 32-bit value without IP addresses. This feature enables OSPF version 3 to be routable over almost any network layer protocol, like other IPv6 routing protocol or IPNG and EIGRP version 6. You must enable it directly to the router interface for the process to work. So, OSPF version 3 configuration requirement: enable IPv6 unicast routing, enable the OSPF version 3 routing process, enable OSPF version 3 on the interface. So configure the passive interface to suppress routing update to and from an interface. So these are just, couple of the. So now the biggest difference between OSPF version 3 and the older, which is OSPF version 2 lay in internal and configuration. OSPF version 3 changed the structure of some OSPF LSA and use more direct approach to configuration, enabling OSPF version 3 on each interface using an interface subcommand. The interface configuration process is just to assign an OSPF version 3 process ID and areas. Similarities between OSPF version 2 and 3, both are link state protocol, both are used same area design concept and design term. Both requires that the routing protocol is enabled on an interface. Once enabled on an interface, both then attempt to discover neighbors connected to the link, to the data link connected to an interface. So both perform a check of certain settings before a router will become neighbor with another router. So a list of checks is slightly different between OSPF version 2 and version 3. After two routers become neighbor, both OSPF version 2 and 3 process by exchanging the content of the link state database, LSDB, the link state advertisement LSA that describe the network topology between the two neighbors. After the LSA have been changed, both OSPF version 2 and 3 use the shortest path first algorithm to calculate the best route to each subnet. So both use the same metric concept based on the interface cost of each interface with the same default cost value. So both use the LSA to describe topology with some differences in how LSAs work. So pretty much this is a brief understanding about OSPF version 3. Why don't we go ahead and pull a packet tracer and start doing our lab today. So now here's this lab. It says configure multi-area for OSPF version 3. So there go the addressing table. Push this a little bit. There go the addressing table. We have all the devices, 3 router A, B, and C. They go the interfaces, they go the IP addresses, and they go the OSPF areas. So it says that on the objective, it says to configure OSPF version 3 and to verify multi-area OSPF version 3 operation. So in background, in this activity, you will configure multi-area OSPF version 3. Network is already connected, so yes, configure. Okay, so guys, why don't we go ahead and start getting our hands dirty on different things that we got to do here. So first thing first, on part 1, we're going to start from router A, which is this router here. What we're going to do is we're going to enable IPv6 routing and configure OSPF version 3 on router A. So let's go ahead and do that. So we do We're gonna put this on enable mode and configuration mode. Then we could do IP version 6, unicast routing. We hit winner. So now configure OSPF version 3 on our A with process ID. So we're gonna do the routing ID. So let's do IP v6 router router OSPF1. So what do we do? Router ID. It's 1.1.1. Okay. So now on step 2, we're going to advertise. We're going to advertise each directly connected network in OSPF version 3 on router A. So we're going to configure each active IPv6 interfaces with OSPF version 3. So we're going to assign each of the area listed in the addressing table. So let's go ahead and do that. So we're gonna say, let's X out just one. Let's say int gig. So is what we've been given the interfaces. So this one here first. And then, so this interface, we're going to say IP version 6, what OSPF 1, 1 and area 1, right? So we could just do up arrow and make the configuration for this one here. So up arrow, let's make this one. Then the IPv6 OSPF. So it's IPv6 OSPF 1 and area 1. So enter. We could do int. Let's do interface. Let's do interface serial. Serial 0.0.0, right? Then we could do SPF. So this, we work with this one here. You could do SPF. They say the area should be what? 0. So area 0. Okay, so now on this step, we're going to configure OSPF version 3 on the 2 other routers. So basically what that is just repeat the same process on the other 2 routers, which is router B and C. Go ahead and pull that. Let's go ahead and add conf T. Then router B, what we do is IP version 6. When I say unicast routing, and then we do IP version 6 router OSPF 1, and we could do router ID, which is 2, so 2, which is 2.2.2.2. Then we could do what we've been given as the interfaces for router 2. Let's make this go over a little bit so we can see router 2, which is router B. So we've been given those. It's pretty simple. So let's go ahead and do that. It's just X out and say interface gig. So gig 0.0, right? Then we could say IP version 6 and IP version 6 OSPF 1, and the area should be 0. So that's what we'll be given here. So area 0, right? So area 0. Okay, so let's go ahead and up arrow and change the interface and do this. So we have the serial now. So serial That's 0, that's 0. Then we could do it up arrow, like the area. So which area it says it should be? I'm sorry. So this one is area 0 again, so we good. Let's make that enter. Then what else we do? We have interfaces. Let's just do up arrow up arrow here, change this to that. That's what we've been given. So this one here, hit enter. And then what area is this? So it says OSPF version 1 area 0. So that's the area we have here. Okay. Now we got to do the same for router C. Just this router here. Let's pull that. Let's just move this over a little bit. Okay, guys. So we have and conf t. Let's say IP version 6 unicast routing. IP version 6 unicast routing. So say IP version 6 router OSPF1 OSPF1 then we gotta go to the router ID. It's 3, yep, it's 3.3.3.3. We have exit out 1 and says interfaces, gigabit internet 0, 0. That's what we've been given here. And the area to be 2. So let's see if we can find it. Okay, so we don't have that yet. So we have to say P version 6 OSPF 1 and the area is 2. So they go to the area that we have to be. It's 2. Okay. So now we just up arrow, we change this to 1. Then we do and the area is 2. Now the last one is serial interfaces. So serial typo. Bad. Oh, okay. So it's serial 0.0.1. That's what we'll be giving here in case if you wonder where to get this one. And the area to be 0 on this one. So say okay, area 0. Right. So now we gotta verify multi-area OSPF version 3 operation. So in this step, we're going to verify connectivity to each of the OSPF version 3. So what we should do is let's ping in. Let's say, okay, so since I'm already here, let's say if we can ping different addresses. So that's what we've been told. Oh, sorry, guys. Bang, bang, bang. So that's where we at right now. So let's see what it was on this router. So let's exit. Let's press end. Let's do ping. And let's grab this since there's no need to paste it and hit enter and see if we can see we got a successful ping. So we good. Let's go ahead and do ping again. Let's see. Let's see. And then it's another one. Gonna get a ping again. So these are the different the different IP addresses that we ping in. So we got an ICMP echo. Let's see, so we get a successful ping again. So let's try this. Yeah. Let's type in ping, then paste this. See if we get a ping again. Okay. So we got a successful ping again. So let's just ping the other IP address. Let's see if we get a ping. So here we get a successful ping again. So that was fast this time. So let's make this one here. Oh, sorry. Ping, 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 ping. So let's hit ping. Then paste. Enter. So that was quick. Round trip time average. That's good. Okay, so now it says that in these steps, what we're gonna do is in step two, use the show comment to examine the OSPFv3 operation. So use the following comment. So let's do this. Let's copy it. Let's paste this here and then hit enter. So let's see what we have here. So this area ID should be 33, and we have that. Let's see, we have SPF. So these are the things that we've been talking about in the lecture. Let's double check. So we get the number of NFSs in this area is 2. I would prefer do this on router 1 to see something. And I have a reason for that. So let's go ahead and start this command process on router A, which is router 1. So let's go ahead and do so let's end that. Let's paste this. Hit enter. So this will be more interesting if we do it on router 1. Router ID, hold time, 10 seconds, minimum SLA, NFS. Interval is 5 seconds, minimum SLA arrive is 1 second. So let's try to. So we get the backbone area backbone is 0. Let's try this on. So number of NFSs in this area is 1. Okay, so let's try this other comment here. Still paste, enter. We get more interesting stuff here, right? Total entry is 12. Entries. Let's grab this. Okay, so let's do command show IP version 6 or SPF database and see. So whatever the database, it's too big. SPF router ID is 111, processing ID is 1, extended area is 0. This one here is 1. Okay. The ID. So and try area prefix link states. So these are the other ones. Tell you what, let's do show IP version 6 or SPF NFSs. It's gonna show all the NFSs that we've configured. We have an adjacent neighbor count is 1, and there go the neighbor. That's what I like about OSPF. So press hello 1. The ID delay. Tell you what, let's just make this. I can see it better. So we get um, so we got gigabit, internet 0, line is up, up. And we should have a serial 1, 2, which is this one. Yeah, so it says it's up. So that's pretty good. So the last command is the neighbor should be the 2.2.2. See what neighbor we have. Yes. Yes, we have neighbor. Yep, with a neighbor. Okay, guys, so thank you so very much. I appreciate you guys was following along with me. That's it for this lab. I appreciate you guys for stopping by. So, like I said, OSPF, it's a very interesting topic. So, if you want to learn more about OSPF, you could always, leave a comment, ask a question, and if we have the answer for it, we'll be more than happy to provide you with an answer. But again, thank you. I'll see you in the next lecture and lab.